Hello students, in this part I will discuss some problems on value of trigonometric functions. So let us start with this question. Question number 1. Find the value of other 5 trigonometric functions if cot x is equal to 12 upon 5 and x lies in the third quadrant. For solving this problem, we will use the sine concept for various quadrants, ASTC rule, because the angle lies in the third quadrant, and you know in the third quadrant tan and cot are positive. Rest of the trigonometric functions are negative. Now let us write an identity which contains this trigonometric ratio cot x. So we have the identity 1 plus cot square x is equal to cosec square x, or cosec square x minus cot square x is equal to 1. With the help of this identity, we can find the value of cosec x. So putting the value of cot x here, 1 plus 12 upon 5 its square is equal to cosec square x. 1 plus 12 upon 5 square is 144 upon 25 is equal to cosec square x. Now LCM is 25. 25 plus 144 is equal to cosec square x, or 169 upon 25 is equal to cosec square x. So cosec x will be equal to plus minus under root of 169 upon 25, that is equal to plus minus 13 upon 5. But because the angle cot x lies in the third, angle x lies in the third quadrant, and in the third quadrant cosec is negative, so because x lies in third quadrant, therefore cosec x will be equal to minus 13 upon 5. Because in the third quadrant, you know, tan and cot are positive. According to the ASTC rule, in the third quadrant, tan and cot are positive. Rest of the trigonometric ratios are negative. So we will consider only the negative sign, because in the third quadrant cosec is negative. Now cot x we already have and cosec x is here, so I can find sin x. Sin x is reciprocal of cosec x, so the value will be equal to minus 5 upon 13, 1 upon minus 13 upon 5, which gives sin x is equal to minus. Now cot x we already have is equal to 12 upon 5, so tan x is a reciprocal of 1 upon cot x. Tan x is the reciprocal of cot x, so this will give you 1 upon 12 upon 5, which is equal to 5 upon 12. So we have got the cot x is already given, we have calculated cosec, then sine, then tan. Now remaining two trigonometric ratios are cos x and sec x. So cos x is equal to, if we divide cos x by sin x and into sin x, and this cos x upon sin x is equal to cot x, so cot x into sin x. By doing this, we have converted this cos x into a such an expression in which we know cot x, we know sin x. Cot x is already given 12 upon 5 into the value of sin x we have calculated minus 5 upon 13. So this 5 and 5 is cancelled here, minus 12 upon 13. So we have got the value of cos x. Now with the help of cos x we can find the value of sec x, which is the reciprocal of cos x. So this is equal to 1 upon the value of cos x is minus 12 upon 13. So this gives the value equal to minus 13 upon 12. So now all the 5 trigonometric ratios are here. Cosec is minus 13 upon 5, sin is minus 5 upon 13, tan x is 5 upon 12, cos x is minus 12 upon 13, and sec x is equal to minus 13 upon 12. This ends the solution of this question. Now next question, question number 2. Find the value of other 5 trigonometric functions if cos x is equal to minus 1 upon 2 and x lies in second quadrant. You can see students here from ASTC rule, in the second quadrant sine and cosec are positive. Rest of the trigonometric ratios are negative. So first let us write an identity which contains cos x. So we have the identity cos square x plus sine square x is equal to 1. We have the value of cos x here, so sine square x will be equal to 1 minus cos square x, or you can say sine x is equal to plus minus under root of 1 minus cos square x. Now from the angle x lies in second quadrant. Second quadrant sign is positive, so I will consider only the positive sign. Since x lies in the second quadrant, therefore the value of sin x, positive value of sin x will be considered. Now putting the value of cos x, which is minus 1 upon 2. So this is equal to plus under root 1 minus square of minus 1 upon 2. And square of minus 1 upon 2 is 1 upon 4. So the value of sin x is equal to under root of 1 minus 1 upon 4, which on taking LCM is equal to under root of 4 minus 1 upon 4, that is under root of 3 upon 4, or this is equal to root 3 upon 2. So with the help of cos x, we have calculated the value of sin x. With the help of cos x, we can calculate sec x. So sec x is reciprocal of cos x, and the value of cos x is minus 1 upon 2. So sec x is equal to minus 2. Cosec x is the reciprocal of sin x. So cosec x is 1 upon sin x, and we have already calculated the value of sin x, which is root 3 upon 2. So 1 upon root 3 upon 2. So this gives the value equal to 2 upon root 3. So we have calculated the 3 trigonometric ratios here. Sin x we have calculated, sec x and cosec x. Now we need to find the value of tan x and cot x. Tan x is equal to sin x upon cos x. No need to give the sign to tan x because the sign we have already considered in sin and cos. So sin x value we have calculated root 3 upon 2, and the value of cos x is minus 1 upon 2. So this is equal to, this 2 and 2 get cancelled, minus root 3. So the value of tan x is minus root 3. Now cot x is reciprocal of tan x, is equal to 1 upon tan x, and this is equal to 1 upon minus under root 3, which is equal to minus and 1 upon root 3. So now 1, 2, 3, 4 and 5, all the remaining 5 trigonometric ratios we have calculated. So this is the final answer of this question. Next question, question number 3. Prove that sin square pi upon 18 plus sin square pi upon 9 plus sin square 7 pi upon 18 plus sin square 4 pi upon 9 is equal to 2. Now let us consider left hand side and convert this radian into degree. Sin square pi upon 18 means sin square pi is 180 degree, 180 degree upon 18 plus sin square 180 degree upon 9 plus sin square 7 into 180 degree upon 18 plus sin square 4 into 180 degree upon 9. Now 18 10 times cancelled and 9 20 times cancelled, 18 10 times cancelled, so this will be 70 degree, 9 20 times, so we get this is equal to sin square 10 degree, sin square 20 degree, sin square 70 degree plus sin square 20 into 4 80 degree. Now sin square 10 sin square keep it as it is sin square 20 degree plus this sin 70 degree, you can write sin theta is equal to cos of 90 minus theta. So you can write this is equal to cos square 90 degree minus 70 degree plus this sin square 80 degree can be written as cos square 90 degree minus 80 degree. So ultimately we get this is equal to sin square 10 degree plus sin square 20 degree plus cos square 20 degree 90 minus 70 plus cos square 10 degree. Now making the pairs, this sin square together with cos square and this sin square 20 degree with cos square 20. So I can write this is equal to sin square 10 plus cos square 10 degree plus sin square 20 degree plus cos square 20 degree. And you know that the identity sin square theta plus cos square theta is equal to 1. So putting this value is equal to 1 and the second bracket also equal to 1. 1 plus 1 is equal to 2 is equal to right hand side. So the question is put that the value of this expression is equal to 2. Next question, question number 4. Prove that sin pi plus x, cos pi by 2 plus x, tan 3 pi by 2 minus x into cot 2 pi minus x upon sin 2 pi minus x, cos 2 pi plus x, cosec minus x, sin 3 pi by 2 minus x is equal to 1. Let us consider the left hand side and draw the quadrants. If I draw the four quadrant, then A, S, T, C rule. First quadrant, second, third and fourth. Now sin pi plus x, somewhat greater than 180 degree, means you are in, this is 0, 90, 180 and 270, 360. So somewhat greater than pi means greater than 180, you are in the third quadrant, and in the third quadrant sign is negative. So sin pi plus x will be equal to minus sin x. And keeping in mind that in case of pi and 2 pi, there is no change in the trigonometric function. Means sin remains sin, cos remains cos. And in case of pi by 2 and 3 pi by 2, sin changes to cos, cos changes to sin, and tan to cot and sec to cosec. Like now cos pi by 2 plus x, cos pi by 2 plus x somewhat greater than 90 degree, you are in the second quadrant, and in the second quadrant sign is positive, rest of the trigonometric functions are negative. Here we have cos, so it is negative, so this is equal to minus sin x. And also because of pi by 2 sin, cos changes to sin into this is into sin, here into sin, then tan 3 pi by 2. In the case of 3 pi by 2 also tan changes to cot. Now the sign of tan, 3 pi by 2 minus x, 3 pi by 2 minus x, you are in this third quadrant, and in the third quadrant tan is positive, so this is equal to cot x into cot 2 pi minus x. Cot 2 pi minus x means 2 pi somewhat less than 360. You are in the fourth quadrant, and in the fourth quadrant cos is and sec are positive, rest of the trigonometric ratios are negative, so this will be equal to minus cot x upon sin 2 pi minus x. In the angle is in the fourth quadrant. Fourth quadrant cos and sec are positive. So this sin will be equal to sin 2 pi minus x is minus sin x into cos 2 pi plus x. 2 pi cos 2n pi plus theta is equal to cos theta. So this is equal to cos x into cosec minus x, and in case of negative angle only cos and sec there is no change in the sign, rest in rest of the trigonometric ratios minus sign comes out, so this is minus cosec x, and into sin 3 pi upon 2 minus x. 3 sin will change to cos, and 3 pi by 2 minus x, you are in the third quadrant, and in the third quadrant sin is negative, so this is equal to minus cos x. So we have here sin square x minus sin x into minus sin x is sin square x into cot square x into minus cot square x. That is the overall sign is negative, sin square x into cot square x upon here minus minus plus and minus sign, and sin x into cosec x is 1, sin x into cosec x is equal to 1 upon sin x, cos x into this is equal to cos x into cos x is equal to minus cos square x, minus cos square x minus minus plus overall minus sign into cos square x. Now solving it further, this minus sign and minus sign is get cancelled, Sin x and sin x is also cancelled here, and this is equal to sin square x, and you know cot square theta is equal to cos square upon sin upon cos square x. This cos sin square x and sin square one time cancelled, cos square x upon cos square x is equal to 1, and this is equal to the right hand side. So the question is solved. We have got the right hand side. So with this question I conclude this part of trigonometry. Like and subscribe my channel for new videos. Thank you, students.